Okay, so Unit 3, we're really talking about a bunch of justifications and stuff. We're going to be relating graphs of f, graphs of f prime, and graphs of f double prime. All of those are going to be related together through stuff we're talking about increasing and decreasing. We're going to talk about things called extrema, which is maximums and minimums on the graph. We're going to talk about concavity and points of inflection. We'll learn what all those mean later on. With Unit 3.1 here, all we really talk about is just basics of f and f prime, and using f prime to determine where f is increasing or decreasing. So for this first example, this graph on the left is graph of f of x, graph on the right is a graph of an f prime x. What we're going to do here, we're just going to list the intervals where each, where f of x is increasing. So this one we're given in f of x, so this one's going to be really simple. If our function is increasing, it's just going to be going upwards, basically. So we can tell the intervals on this graph on the left very easily. So we can see that it's moving up this way from -3 to -1. So -3 to -1, that's our first interval. I wrote parentheses there, that was my bad, actually. If we look, both -3 and -1 are actually included in the graph, so we would do brackets here. That was my bad. If we're going to check here now, -1 to 3, that's going to be decreasing. But if we go back from 3 all the way up to infinity, it's going to be increasing again. So that's going to be our next interval. So 3 is included to infinity. Infinity is not exactly a point, so we do parentheses there. This is increasing on this graph. And if we're going to do decreasing on this graph, it's just going to be the only interval we have left, the one we skipped over. This is going to be from -1 to +3. So -1 to +3. And that is our increasing, decreasing intervals for this graph. Now over here, on this other graph over here, this is a graph of f prime. It's not the same f prime of this f of x graph, but it is an f prime graph, so it's a derivative. So we're going to have to think a little bit more. And we want to find the same thing where f of x is increasing or decreasing. And so we know derivative represents slope. So when f of x is increasing, that means the slope is going to be positive. And when f of x is decreasing, the slope is going to be negative. So the way we're going to think about this is when we look at f prime, if it's a negative value, a negative interval, that's where f of x is decreasing. And if it's a positive interval, that's where f of x is increasing. So we're just going to, I'm going to write it up here. I think this is outside of that light spot from my light on the ceiling. That's making this a hard video to film, but I think this should work. So let's just go through looking for these intervals. So there's an arrow downwards, so this is going to be starting at -infinity. And remember, we're looking not at increasing, decreasing on this graph, we're looking at positive, negative, because that's what affects increasing, decreasing on f of x. So it's negative from -infinity all the way until this point right here. And that is going to be at -4. So decreasing is going to be -infinity to -4. And then it changes to a positive part, so this means f of x is increasing. From -4 until this point right here, which is the origin, so this is going to be 0. So for our increasing interval, one of them we have is from -4 to 0. If we continue downwards, after 0, it transfers back to negative again, and it's still negative all the way until 5. So adding on to our decreasing interval, we're going to have from 0 to 5. And then it switches back to positive from 5 to 6. So for our increasing interval, we are also going to have 5 to 6. So that's basically how it works when we're making determining increasing, decreasing with different graphs. If we're given graph of f of x, and we want increasing, decreasing on f of x, it's plain and simple. You just look for increasing, decreasing. If we're given f prime, and we want to know where it's increasing, decreasing on f of x, that's when we determine where if it's positive or negative. A negative value on f prime is going to be decreasing in f of x, and a positive value of f prime will be increasing in f of x. Alright, so this concept of relating the positive, negative values of f prime to increasing, decreasing of f of x does not just apply to graphs. It actually applies to when we're given functions. So here, we're given f of x equals all this stuff, a polynomial, and we want to find whether f of x is increasing, decreasing, or neither at these 3 points, and then we want to find the intervals of increasing, decreasing, and stuff. So Remember, to figure this out, we need to know whether the derivative is positive or negative and stuff at this point. So let's find the derivative first. So f of x is all this stuff. So f prime of x is going to equal, it's all just power rules, so I'll just read it term by term. 1/3 x cubed turns into just x squared. 3x squared turns into 6x. Minus 16x turns into minus 16. And that minus 7 just turns into a 0, so we'll leave that off. So what we're going to want to find is f prime of 4, f prime of 0, and f prime of negative 8. So let's start off with 4. If we plug in 4, we will get 4 squared plus 6 times 4 minus 16. 4 squared is just 16, and this minus 16, so those two are going to cancel. We're just going to be left with 6 times 4, which is 24, which is a positive value. And so if we resulted in a positive value for f prime, then that means f of x is going to be increasing at this point. So a lot of these problems are going to require justification. So if we want to justify that f of x is increasing at x equals 4, we will say that increasing at x equals, or we should say f of x is increasing. We have to actually identify what function we're talking about. So f of x is increasing at x equals 4 because f prime x, or not f prime x, my bad, f prime of 4 is greater than 0. And that follows what we've been saying this whole time. If the derivative is positive, it's going to be f of x is increasing. So that's where that comes from. Now, let's do this again, but with f prime of 0. This will give us 0 squared plus 6 times 0 minus 16. 0 squared is just 0. 6 times 0 is just 0. So we would be left with negative 16, which is a negative value. And so for a negative value, we have pretty much the same justification, just slightly different. Here we're going to say f of x is decreasing, and that is because f prime of 0 is not greater than, f prime of 0 is less than 0. And again, that follows what we've been saying this whole time. If f prime is negative, then that means that f of x can be decreasing. And so lastly, what we're going to do, we're going to do the same thing again, but with x equals negative 8. So plugging in negative 8, we will get negative 8 squared plus 6 times negative 8 and minus 16. Now, negative 8 squared is going to give us 64. 6 times negative 8 is negative 48, but negative 48 minus 16 is actually going to be minus 64. So we're going to be left with 64 minus 64. That's just going to give us a 0. 0 is not positive or negative. So when we result in 0 for f prime, this means that f of x is neither increasing nor decreasing. If you have to justify that, you just say that because f prime of our value, in this case was negative 8, so f prime of negative 8 is equal to 0. And that is your answer. Now that answer is part A, but remember there's a part B, where we want to actually find the intervals where f of x is increasing or decreasing. And so the thing we've been saying is that if f prime is positive, f of x is increasing. F prime is negative, that means f of x is decreasing. But we can't actually get intervals from just that on its own. That just tells us for a specific point. However, we do know that the only time that something can change from increasing to decreasing, that means that it's going to change that at some point it equals 0. So if we could find all the time f prime x equals 0, what we could do is we could put each of those points on a number line. We can test different values in between those points on the number line. And that will tell us, like, maybe we plug in a value here, it's positive, a value here, it's negative, a value here, it's negative. That will actually give us our intervals. And again, the reason this works is the only way a graph could change positive to negative would be points that equal 0. So if we have all the points that equal 0, that means between those points, they're either going to be all positive or all negative. And so that's how this idea is going to work. So to do this, remember we have to find the points that equal 0. So let's set the derivative equal to 0. So we're going to say f prime of x equals 0. And if we write that differently, it'll be x squared plus 6x minus 16 is equal to 0. And now we have to factor this, and I can't think of how to factor that at the top of my head, so I'm just going to scramble here and Do that? Yeah, so we're going to get x plus 8 times x minus 2 equals 0. And from that, we will get x equals 2 and x equals negative 8. And now, like how I brought up that number line earlier, we could do that. And we are going to plug in, or not plug in, but as our 2 points on the number line, we are going to put 2 and negative 8. So negative 8 is over here, and 2 is over here. And so now the question is, do we plug it into the derivative, or do we plug it into our actual function? And the answer is the derivative, and that's because we're trying to find where the derivative is positive and negative. We're not looking at actual f of x at all. So we're going to plug in values between these intervals. So like between negative 8 and 2, 2 and on, and before negative 8. We're going to plug in values from these points into f prime, and whether it's positive or negative will inform us about this whole entire interval. And so you're going to want to pick easy numbers. And so between negative 8 and 2, a really, really easy number is going to be 0. So let's just plug in 0. And you could plug it into f prime right here, which is just a longer thing. And in this case, plugging in 0, that's perfectly fine. Plug in 0, these two terms cancel, the x squared and the 6x, because 0 squared is 0, 6x, or 6 times 0 is 0. So these go bye-bye. We're just left with negative 16. So we get a negative here. But most of the time, we actually want to plug it into our simplified version, which is this one right here. Remember, these are all the same function. They're just modified. And it's typically easier to plug it in here because you could see the numbers faster or whatever. And that's actually going to come into play with these two values. So we could plug in 3, we could plug in 4 or something, but what's really nice with this is you could plug in just like a billion. And a billion is really easy to see because a billion minus 2, we know that's going to be positive. We're not really caring about the numbers. We just want to know if it's positive or negative. So a billion minus 2 is positive, and a billion plus 8 is positive. So positive times positive is going to be positive. So that means way over here, it's going to be positive all the time. We can do the same thing over here in this negative infinity to negative 8 interval. What we can do here, just plug in negative a billion. So negative a billion minus 2, that's still negative. Negative a billion plus 8, still negative again. So negative times a negative, we know that's positive. So here we're going to have positive as our interval. And because we found all of these intervals now, we can actually just write where f of x is increasing and decreasing. So we know that for increasing, this is when f prime is positive. Those are these two intervals right here. So from negative infinity to negative 8, union, from 2 to infinity. And if we're talking about decreasing, it would be this middle interval right here. And that would be negative 8 to positive 2. And that is how you find your intervals of increasing, decreasing, given a function. Now, this whole idea actually also applies if we're given a table of values. It's not exactly nice to see here, and I know some of the writings there in this lighting spot right here. Hopefully I'll fix that in editing. I don't know. If not, I'll just talk about it. But here we're doing the same thing. We want to find intervals of increasing and decreasing. Looks like my marker's kind of starting to die, but we'll work with it. So, remember, we're thinking about f prime, and so f prime's positive, then that's an interval where it's increasing. F prime's negative, interval for decreasing. So we start with, so through here, we're given x values, 0, 1, 2, and 3. We're also given intervals, 0 to 1, 1 to 2, 2 to 3, 3 to 4. So, for the bottom row of the table here is f prime. So at 0, it's 4, 0 to 1 is positive, and then at 1, it's 0. So we know it changes at 1 right here, and it's positive all the way before that. So this is kind of like a closed interval. We only have the interval from 0 to 4 in this table. So for increasing, we know it starts at x equals 0, because we had a positive value there. And then we know it goes all the way until x equals 1. X equals 1. We know that because it's going to be 0 here. However, if we keep looking right after, it's going to be positive again. And so because it's positive again, we're not going to just put 0 to 1 and then 1 to here 2 when it's past positive, whatever. What we're going to do is we're just going to treat this part where it's 0, we're just going to ignore it. The reason for that, the graph probably looks something like this. It's like bouncing across, bouncing after it hits the x-axis. It's not going through, it's bouncing. And so when it's bouncing, it's not changing positive to negative. and so that means that it's not going to be changing, increasing, and decreasing on the normal graph. So we know it's increasing starting at 4. Here it's, starting at 0, my bad. And then it's positive here. Then it's 0, but it's still positive. So this whole long interval is going to be positive. Here, it says that f prime x does not exist. So that means that we're going to have to cut the interval there off no matter what, because it does not exist. So when it does not exist, the x value is 2. So we know it's going to be positive all the way from 0 to 2. 0 is going to have a bracket because it's included. But because 2 does not exist here, we're going to be putting our parentheses. That took a minute to say, whatever. If we look at f prime now, after 2, it's negative. So that means it changed there. So that means it's going to be decreasing there. So we're going to start at 2. Have the parentheses there because it's not included. So we're going to look past 2. From 2 to 3, we're going to have a negative interval. So that's still negative, so still decreasing. Then we're going to have a negative 3. That's still decreasing again, or negative, whatever. Then it changes to positive. So that means we know from 2, or where is it? Yeah, 2 to 3, we are going to have a negative, or a decreasing interval, I should say. Decreasing interval because f prime is negative. And if we check right after 3, it's going to be positive again. So the interval from 3 to 4, that will be an increasing part of the interval. So it's the same thing we've been doing, where if negative f prime, it's decreasing f of x, and positive f prime, it's increasing f of x. It's just a bit harder to see on the table, but if you have that concept down, you should be able to figure out. This is just the way it works. All right, so we got another one here. These are our last 2 problems, and they're going to be both with these 2 very poorly drawn graphs. This one's f of x, this is g of x. So I couldn't really draw the graphs great, but I do have all these like units here, the dashes, whatever. So that'll actually help us hopefully better see the actual values. So f of x is just this graph, whatever, nothing special. G of x, it's a parabola right here. Kind of hard to see. Let me attempt to darken that. And it says we have a tangent line here, and the line is tangent at 0, negative 1, which is this point right here. As well as the fact we are told that we have a point at 2, 3. So using this information, we're given that h of x is going to be equal to f of g of x. And what we're solving for on this one, we want to know if h of x is increasing, decreasing, or neither when x equals 0. So if we want to find that, the same thing as always, we have to check positive or negative of the derivative. So let's derive h of x. H prime of x is going to equal, this is going to be chain rule. This would be f prime of g of x multiplied by g prime of x. If you want more help with chain rule, I have a whole video on that in Unit 2. So now what we want to do is we're going to just plug in 0 into h prime. So h prime of 0 will be f prime of g of 0 multiplied by g prime of 0. So now we're going to have to go do some detective work within all of this. So the first thing we have is g of 0. So g of 0 is, so remember g is the parabola, and we are told there is a tangent line to g at 0, negative 1. If there's a tangent line to a function at a point, that means that they share a point, that point. They're both at that point. So there's a tangent line here at 0, negative 1. That means that g of x also passes through 0, negative 1. So that means the y value, so g of 0, is just going to be negative 1. So plugging that in, we will have f prime of negative 1 now. And then we're still multiplying by g prime of 0. So that means we're going to look for the slope of g at 0. And it's a parabola. We don't have an easy way to find the slope. We're not given a function, so we can't find the derivative and find the slope. However, we can use the tangent line again. We can find the slope of the tangent line, and that will actually tell us the slope of g at that point. And this is the one we're going to use, the fact that we have this point and this point given to us. So we're given 0, negative 1, and we're given 2, 3. So this is up 1, 2, 3. Yeah, up 1, 2, 3. Oh no, 1, 2, 3, 4. Up 4 and right 2. My bad for struggling on that. So rise over 1, forward 2. That's the same as 2. So the slope there is going to be 2. So f prime negative 1 times 2. Now we just have to find f prime negative 1, and we can basically get our answer. So this is going to be the slope of f at negative 1. And so that's going to be asking us for the slope of f at negative 1. That's going to be the slope of this line thing right here. So it starts here at 0, negative 2. So it starts at 0, negative 2. I didn't label it, but that's what the point is. And it ends over here at negative 3, 4. Negative 3, 4. So rise over run again. This is up 1, 2, 3, 4, 5, 6. And it's right 1, 2, 3. So 6 over 3, and that's going to be 2. But remember, this is decreasing right here, so it's going to be a negative 2 for our slope. So f prime of negative 1 is going to equal negative 2, multiplied by the 2 we already have. That means that h prime of 0 is going to be negative 4. Because it's negative, that means that h prime of negative 4, or no, h of negative 4 is decreasing. Because h prime of negative 4 is less than 0. And that is the first question involving this. Alright, same type of thing here, just we're given a different function for h of x, so this time h of x is going to be g of x over f of x, and we're going to be finding increasing and decreasing neither at x equals negative 2. So now we're going to derive h of x again, we're just going to get a different derivative this time. So if we derive g of x over f of x, that's going to be quotient rule. And so remember quotient rule, it's going to be derivative of the top times the bottom minus derivative of the bottom times the top all over the bottom squared. So for us, that would be g prime times f minus f prime times g over f of x squared. And so now we're just going to plug in negative 2. So h prime of negative 2. I know I'm making that sound simple, but we got a lot of plugging in to do. So it's not terrible in terms of how difficult it is. It's just a lot of work. So let's get to work on this. We're first going to need to find g prime of negative 2. So the slope of g at negative 2. And I might have drawn this a bit way too off scale. I did. I drew this so g of x here, it looks like the vertex. The way I drew it, the vertex looks like it's at negative 3. The vertex here is actually at negative 2. And so because of that, that means negative 2. We're looking for the slope of negative 2. And the slope here at the vertex, it's 0. Because you could draw a horizontal tangent here, so the slope is 0, whatever. So g prime of negative 2 is going to equal 0. And that means we don't have to calculate f of negative 2, because 0 times anything is 0. So we don't really care what f of negative 2 is. We don't have to worry about that, for right now at least. Next we're minusing f prime of negative 2. So let's go to where negative 2 is. And f prime of negative 2, it's going to be the slope of negative 2, but we actually calculated that last time. That we might not have calculated it at negative 2, but it was in this interval. And remember, last time we said that was a negative 2 itself. So f prime of negative 2 is going to be negative 2. So now we have g of negative 2. And this one we're actually going to look for what the value of g here is at negative 2, not the slope. So the value here at negative 2, it would be, it's left 2, and we are going down about 3. I drew it terribly here. Ignore the fact that I drew it terribly. But what it's going to be is negative 2, 3. So that means we will have 3, or negative 3, because this is below the x-axis. I'm misspeaking a lot. I hope that even amongst that, I'm helping someone. My bad. Over f of negative 2. So we do have to actually find f of negative 2 here, and f of negative 2, and I really am just looking at my own the actual paper graph, because I drew this bad. I can't exactly show a good graph because I can't draw. But f of negative 2 is going to be 2. Remember, it's squared. So this first term was all 0, that canceled out. This term we have minus a negative 2 times a negative 3. So that's going to equal a negative 6 in the numerator, 3 negatives. And here we have over 2 squared, so that is going to be over 4, and that is negative. And so because it's negative, we know that that means that h of negative 2 is decreasing, because h prime of negative 2 is less than 0. So I know with this kind of, this two graph kind of problem, the fact that I have the graphs really not drawn to scale kind of messed with it a bit, whatever. But I hope I kind of convey the idea across. Basically, you're just checking the values. If it's f prime, you're looking at the slope. If it's f of x itself, then you're looking at just the graph itself. And remember, if you have a tangent line, that does tell you more information. And just be aware of that information so you actually can solve for all the stuff you need to. And all in all, that pretty much wraps up 3.1.